Hey there, Mr. Sutton here with the Pre-Cal Honors 2-6 Extra Practice Number 2 solutions on writing polynomial functions. To write out the possible equation of this polynomial, let's start by finding the overall sign. So as I move to the far right, we're going up. That tells me that this is a positive polynomial. So I'm going to write y equals, and then there's kind of an invisible plus sign right there. Now looking at my factors as I move from left to right, we start with a 0 of -6. So that's a factor of x plus 6. And since we're crossing through without doubling or without bouncing or flattening, this is going to be a single root. So this is just x plus 6 to the first power. Next, we go through -4, but we're bouncing there, so there's a double root there. That means I have to write x plus 4 squared. And for this one, we're flattening through 1, which means we have a triple root there. So this is going to be x minus 1 cubed. Well, that's cute. We got one of each. For writing the possible equation on this one, let's first get the sign of the polynomial. Since we're going down and to the right, that means we have a negative overall, so I'll write y equals negative, and then we'll get some factors to go with that. Since we have a 0 of -8, we have an x plus 8 factor, and since we're crossing straight through there instead of bouncing or flattening, that means this is a single factor, single root, so x plus 8 to the first power. And then we're going through -3, but we're flattening as we do so. So that's a triple root. So I have to write x plus 3 cubed. And then we're going straight through +3, so that's just going to be x minus 3 to the first power. To get a possible equation for this polynomial, first we have to know the sign of the polynomial. So to find that, let's look at the end behavior as we move to the right. We're going down as we go to the far right, so that's a negative polynomial. So I'll write y equals negative, and then we'll fill in the rest here with the factors. So from left to right, we have a 0 of -7. That means I have a factor of x plus 7. Since I'm crossing straight through there without bouncing or flattening, that's a single root, so we write just x plus 7 to the first power, which we don't have to write the little 1 up there. Now we're also crossing straight through -1. So that's a factor of x plus 1, again to the first power. We are bouncing at +2. So now I have x minus 2, but because that's bouncing, that's a double root, so I have x minus 2 quantity squared. For this one, we're trying to get a possible equation for this polynomial. Let's start with the sign of the polynomial. Since I'm moving up as I move to the right, that's a positive polynomial, so I'll write just y equals, and then there's kind of an invisible plus sign there. For my factors, the first 0 I encounter is -7, so I have a factor then of x plus 7. But since we're bouncing there, that's a double root, so I have to write x plus 7 quantity squared. And let's see, we're going straight through -3, so that's a single root there. So that's going to be just x plus 3 to the first power. And we're going straight through 4, crossing 4, so that's going to be x minus 4 again to the first power. To figure out the specific equation for this polynomial, I'm going to start with a more general equation with an a out in front of everything. So let's see here. Let me figure out the sign of this polynomial first. Since we're moving down as we go to the far right, this is a negative polynomial, so I'll start by writing y equals negative, and then I have that a out in front as well. Now let me write down the factors with x's. Since we're going through the origin, I know I have an x minus 0 factor, or just x, and since we're bouncing there, that's a double root at 0, so I have to write then x squared. Now we have this other one at -4. So that's a factor of x plus 4. Since we're crossing through, that means that's just first power, so x plus 4 to the first, which we don't have to write the first power there. So this is a more general equation for the polynomial, but it's not specific until I find that a value. To get that, I'm going to plug in the point they gave me, -2, -6. So I've got a y value of -6, and I'm going to plug -2 in for all the x values. So I have -a times -2 squared times -2 plus 4. -2 squared, that's +4, and we're multiplying that by the 2 that's left over in the parentheses. So that's going to be 8, so -8a for the right side. And then dividing by -8, 3/4 is what I can reduce that to. If I have 6 over 8, that reduces to 3/4. So using that a value of 3/4, let me rewrite what I wrote up here. This is going to be y equals -3/4 x squared times x plus 4. To get the specific equation for this polynomial, let's start with the general equation using a to kind of represent the unknown mystery constant that I have to put out in front of all this. So for the overall sign of the polynomial, we're moving up as we go to the right. So that's a positive overall polynomial. So I'm just going to write y equals positive a. And then for the factors, we're hitting 0, we're bouncing at 0. So that means I have a factor of x minus 0, or just simply x. Since I'm bouncing there and have that double root, that's actually going to be x squared. And now we're crossing through 4, single root at 4. So that's going to be x minus 4, and that's just the first power, which I'm not going to bother writing the first power. Now, in order to get the a value, I still need to plug in this point -3 comma -5 for x and y. So for y, I've got -5 getting plugged in there. And for x, the -3, the x value of that point. So I can write a times -3 squared times -3 minus 4. -3 squared is 9. -3 minus 4, that's going to be -7. 9 times -7, that's going to be -63. So I have -63a. Dividing by -63 to get a by itself, I can write positive 5 over 63, which I can't really reduce. Next, let me plug this into the original that I wrote up here to get a specific equation. So we have y equals 5/63 x squared x minus 4. On this problem, I want the specific equation for this polynomial, but let's start with a general equation with an a out in front. So let's first get the overall sign of the polynomial. As I move to the right, I'm going down forever here. So that means I have a negative polynomial, so I'm going to write y equals -a to start with. Now let me get the factors with x's in them. We're crossing through the 0, -9, and we're crossing through rather than bouncing or flattening, so that's a single root at 9, -9. So that means I'm going to write the factor x plus 9, x minus -9. And that's, again, just first power, which I don't have to write. Now, over here at 3, we are flattening as we move through 3. So I have the factor x minus 3, but now since that's flattening, that's a triple root, and I have to write x minus 3 quantity cubed. Now to find the a value. So to get that, I plug in this point that they gave me, 2 comma 4. So I have a 4 for y, and a 2 for all the x's over here. So that's -a times 2 plus 9 times 2 minus 3 cubed. Well, 2 plus 9 is 11. 2 minus 3 is -1. And cubing that, it stays -1. So I have a -11 times a -a, which gives me a positive 11a. Dividing by 11 to get a by itself, we have 4/11ths for the a value. And then plugging that back in up here, we have -4/11ths, x plus 9, x minus 3 cubed, as my specific polynomial function.